Yes, very good morning to all of you. Very good morning. And so far we have completed unit number 5 also. More or less, one or two topics have been left over in unit number up to unit number 5. Now, so today, probably for 3 to 5 days, we will concentrate on Unix laboratory, because Unix laboratory is one of the important aspects of your practical approach. So let us take into consideration and let us do some kind of exercise on Unix laboratory here. Let me show you what are the components of the Unix laboratory which are available with us. So let us see the operating system and the Linux programming. This is our programming, our laboratory. OS and the Linux programming both will be combined together, will be considered as our programming laboratory. And operating system will be taken care by Naresh Garu, because he is the person who is dealing with you. So right away from first to seventh problems, simulate CPU scheduling algorithms, that is round robin, HFM, CFS, and so on and so forth. The memory, fork, wait, and exec system calls. Of course, I will discuss what is fork, what is wait, what is exec, and what is exit. All the system calls. This could be done by me only. And MFT, MVT, deadlocks, and deadlock prevention, FIFO, LRU, all these methods are being done by Naresh Garu, except the second program. Okay, so multi-programming and memory management systems. These two, this particular second point will be taken by me. And as far as Linux programming is concerned, we have already discussed something about the first one here. So what is CAT, what is man cat? Okay, and then the process state, and so LS, MB, RM, RMDIR, RM maker, all these things have been discussed by us. And already we have seen what is the tree structure of our Unix file system. Everything has been seen here. Everything has been done. Now we'll enter into second program. So right away from second program onwards, totally we have 8 programs are there. First program is absolutely related to basic Unix system, and second program onwards, it is completely related to what is that, C programming under Unix environment or Linux environment. Okay, so we are trying to evaluate all these things. So to evaluate all these things, we need approximately some 7 to 8 classes for each and every program. We are especially required some 9 classes. 9 hours must be required here, because there are some system calls which are very much useful for us to discuss. So I'd like to discuss some system calls. Then so we'll go ahead with discussing about all these points here. I mean, problem number 2, problem number 3, problem number 4, and so on and so forth. Everything will be discussed with you. Okay, so that is the point I would like to made here. So I'll give you system calls today. So already in unit number 2 of your operating systems. Otherwise, in unit number, I think unit number 1. So in operating systems, so your operating system, sir, has been discussed that what is that, system calls. There are certain number of system calls which have been discussed with you by operating system, sir. That is Naresh Garu. And I'm also discussed with you that thereby system calls cannot be discussed with you in depthly. So I have been discussed everything in depthly. So what exactly the system call could be, and how the system call could be gets evaluated. After taking 1 or 2 classes, today's class and tomorrow's class, let me finish off all the system calls. Then we'll come back to each and every program here. Okay, we will develop each and every program together. Okay, so let us see what is a system call and how the system call is being taken into consideration, and what exactly these system calls could be. So system call in the sense it is certain kind of interface between so operating system and kernel and user operating system and kernel. It is certain kind of system interface between these two. Before going to take a system call, so there are a certain number of points which we'd like to remind ourselves. That point will be there are some you may be right, you may be written several number of functions, you may be written several number of system calls. Of course, system calls have not been written by you so far, but functions, you may be prepare your own functions and you may be call your functions something like this in our main program. Let me consider, if you consider our C programming language, so you may be write some main program, something like this main, and so some particular function which could be called by you without arguments or with arguments, however, whatever it may be, that doesn't matter here. And this particular function could be so written something like this, and it could be gets executed somewhere something like this. You may be call your function something like this. What is the basic difference between these two? What is the basic difference between function call and system call here? That is the point I'd like to discuss. Okay, the point will be we need to understand. So basically, function call could be always evaluated by a particular process and with its memory. Okay, it is not supposed to go in depth. Okay, let us consider this area will be so process, and this process will be initiated a function call. Okay, this function call could be obviously called this particular function, and which could be allocated within the space of within the scope of this total process only. So here you may be written one particular program. The program name will be add.c. For example, add.c is a process here. You please understand whatever the program name you have written here, that particular program name will be considered as the process here. Within this particular process, you have a main function, and you do have one more function, that is add. Add is one particular function, and you maybe take a subtraction, another function. You maybe take a division, another function. Something like this. You do have many. Out of this, one particular function will be called. What would be happening? Soon function will be called. So your main program will be gets so taken off, and it will be scope of or execution pattern will be gets changed from this function call to so where exactly the function has been defined. After completion of your function, so the pointer will be the execution pointer will be returned to the called area here. Okay. The point you need to remember, the caller and the calling. This is the caller, this is the caller, and this is the calling. Okay, these two are two different types of names, caller and calling. Both will be in the scope of same process. Okay, for example, it could be allocated some 750, so hexadecimal to so some 1050 hexadecimal. This is the address space where exactly the process will be gets executed. In the sense, main program will be allocated in the same process, same area, and our called function could also be allocated in the same area. It should not be go beyond that particular locations. So that is what the point which we'd like to consider regarding to the same process. Okay, and here you need to remember one or two points here. The points will be so at the same area, at the same user area. So your function could be gets evaluated, and your function could be gets executed. And here both will be available at the same domain of trust in the sense. So your process will be gets allocated for during this particular memory spaces. So totally 750 to 300 so bytes or kilobytes or megabytes, however whatever it may be, 300 memory units will be gets allocated here. So during this within the scope of this 300 memory units, your process will be gets executed. It shall not be go beyond that particular place. Whereas if you consider the same thing in terms of so system call, if you take the consideration of system call, what exactly it could be? Okay, a system call could be always called by a process. Okay, it is obviously so you must call the system call, As and when you have to system call this, it's also be seems as like as a function call. So look at this, whatever the structure you have taken in the function call here also same. So the same function call could be taken into consideration. When system call will be called by the process or by your program, immediately a request will be sent to operating system. Okay, so probably you do have many number of system calls. We'll discuss in future probably. So today I'd like to discuss one particular system call, what actually been happening here. Okay, a request will be made to the operating system. Obviously operating system will be soon, the system call will be received by the operating system. Operating system will be made some kind of setup. Very huge setup is there. I will discuss in the forward slides. After completion of execution of this whole thing, then it will be returned. I mean, operating system will be returned to caller area to execute the next statements, whatever the next statements of the system after system calls, it could be taken. So this is the basic difference between these two. Basic difference might be, okay, let me discuss. Operating system is always a trusted party, and the user must be always not trusted party with respect to operating system. Here, within this particular area, we have considered that the process is a trusted area. Look at this, the domain of not R here, this is of, sorry, domain of trust. Okay, it is domain of trust. But here, as and when operating system will be comes into the picture, process will be domain of untrust, because process will be gets executed somewhere else. Operating system will be executed somewhere else. Probably your teacher, your operating system teacher has discussed something about phasing, country keys allocation, and segmentation. Everything has been discussed. Thereby, you got some kind of idea. So where exactly operating system will be resides, and how operating system will be protected while allocating space for some processes, user processes. Already you have some idea, I think. Yeah. So operating system will be always trusted. Without operating system, your system cannot be executed anymore. So with respect to, or in the view of operating system, your process will be, or your user will be, your user area will be untrusted. If your user area will be overlapped with operating system, obviously the total entire system will be gets corrected. Okay, corrupted. So then operating system does have all privileges. Okay, reading, writing, and communication with devices, communication with hardware of your system, every privilege could be have by the operating system, whereas user does not have those many number of privileges. User could have only one privilege, that is accessing of memory. That's all. Okay, no other privilege could be taken into consideration. Then, so you must ensure that to prevent the abuse. What do you mean by abuse here in the sense? What is the importance of this particular abuse here in the sense? As and when any system call will be called by your process, that particular system call must be, give certain number of whatever the required number of parameters. Okay, required number of parameters must be given. Without a given required number of parameters, obviously your system call could not be executed. So that is what the abuse does means. And second point, abuse in the sense, as and when you have to call a system call, obviously it must not be overlap the memory where exactly operating system resides. Okay, it must not be so overlap the memory where operating system is resides. So these 2 points will be always considered as abuse. Okay, as far as operating system is being considered here. Then look at this. So some definitions regarding to a system call here. Already I told you it is a fundamental interface between the application or process of you and the Linux or Unix kernel. Okay, Unix or Linux kernel is general. So fundamental interface between those two. And also, the system call could be make a request or made a request to the operating system to perform certain kind of activity. What kind of activities in the sense? Wanted to create a file. So you need to operate CREAT. Wanted to open the file. Yes, you have to open. You have to operate. So open. Wanted to write onto the file. Yes, write. So write operation is being done here. Wanted to read from the file. Yes, read operation could be done by you. Done by here. So done by you here. So wanted to read the data at random. So lseek. Lseek operation will be done by here. Okay. So these are different kinds of system calls. If you want to create one particular file, so there is no specific function to create a file in our general C programming language. If you want to create a file, so you must use open only. Fopen could be used, and based on the mode, you may be apply for create a file or appending the file or read mode, write mode. Several number of modes will be taken by the fopen function, which is being defined at what is that stdio.h. Okay, so thereby it could be done. It could be always done, or it could be always written a pointer. A pointer could be written, and that particular pointer could be manipulated by you using some kind of variables of your program, of your process here. Whereas these are all different kinds of system calls. As and when you have to operate such kind of system calls here, obviously operating system will respond for our call, and it could be performed. So if you want to create a file, yes, it is going to create a file. It is going to activate the hard disk in the sense of secondary storage device, and it could be make sure that the file is not available. If it is the file is not available, obviously it could be gets created. The file will be available immediately. Error message will be gets generated to you. Something like that. Some kind of operations, certain kind of operations are going to be performed by the system calls. Not only file operations, you do have inter-process communication and process communication. Many other kind of system calls are available with us. We will discuss one by one. And then system calls are very expensive. As and when you have to call a particular system call, something like this, these are very expensive. What is the meaning of expensive here? Expensive in the sense, when you have to call a simple system call, it could be seems as like as a single function, but internally it could perform many operations. What are the operations it could be performed? Because of many minute operations which are being performed by the system call, it could be called as very expensive. Okay, that is the meaning, very expensive. What are the operations which could be done? First operation could be, so it could be always access the computer hardware. After accessing, so before calling the system call, what is the state of your hardware that must be saved that particular state. To save that particular state, we must require some number of registers. So registers usage will be available. And then operating system code will be take the control of CPU, and some number of privileges will be gets updated here. Means the total control will be taken by the operating system, and then followed by operating system will be examine whether called parameters will be proper or not. It could be examine everything is properly available or not. Then after taking, so if called parameters will be gets completed, then it could be perform the requested operation, whatever the requested operation you are requested on behalf of you by or through system call, it could be performed. Then followed by operating system must be save the state, and the result will be sent back to the user. I will explain one particular such kind of a system call. So in the next slide, okay, what are the sequence of operations which could be done in the next slide. These are the different kinds of micro operations which could be done as and when any system call could be called by you. So during execution of any system call through C or C++ or Java or some other programming language. So that is why it is very expensive. That is the reason we have to say very expensive. You may be called just one line of code. So since one line of code will be taken by you, it could be causes to evaluate this many number of operations. So that is why it is very expensive. And also specifies that, of course, C2 returns the caller. Okay, that is not a big deal. If any system call could be evaluated by you or executed by you, if it is discovers that it is having some kind of error, it is unable to do the process of process what you are expected, then it could be returns -1. Whereas in functions, fopen fopen is one particular function, and then fread is another function. So fwrite or fprintf is another function. So all these are belongs to file operations in terms of C programming language. Whereas if you are perform these operations, this may be returns a pointer value, otherwise a address. Any address will be written. Otherwise, null could be written. Null could be written here. But system calls, if it is having some kind of error, obviously it could be returns -1. Okay, -1 will be indicates that your system call has not been executed properly. Obviously, what is the cause to generate -1 by that system call will be provided with one particular variable, that is error_no. error_no. All these errors have been defined with so hash include error.h. Okay, with error.h you have all these errors. Okay, so for example, wanted to create one particular file, but that file is, the name of that particular file is already existed within the present working directory. Okay, file does existed, so that is the error message. So it could be returns -1, and associated message will be file is already existed. Wanted to open a particular file, for example, if you want to open one particular file, but that file is not found, actually that file is not there, the name of file could not available, so within the present working directory, then what shall it could be? It could be returns open could be returns -1, and associated error number will be file not found, where exactly the file not found will be there. So thereby so-called error message will be generated. Okay, something like that will be happen continuously while system call is being taken into consideration. Followed by, if it is successful, if it is successful, then it could be written other than -1. Obviously, as far as system calls is being concerned, other than -1 in the sense, most of the cases it could be written 0. Most of the cases it could be written 0. Some other kind of system calls are there. Those system calls could be written so more than 0 value. So that is why it has been given that other than -1. If other than -1 value could be there within your system call, then it has been successful. Okay, your system call is completely executed by operating system and CPU. And if it is successful, previously, for example, previously same system call was unsuccessful and error message was generated, and that could be stored somewhere else in error number error_no has been having some kind of value. If it is for the next time, so system call is get succeeded, so that it could not be clear that error number. Okay, whatever the previous error number, so it could be always maintained as it is until next error will be get secured. Okay, so that is the point where exactly we need to consider. Then, okay, so then look at this. I'd like to explain the read system call. What is the, because read system call is very much expensive. If you consider all other system calls, read system call is very expensive. How it could be? Let me explain by taking one small example here. Normally, the read system call could be taken so with this particular kind of syntax: read file descriptor, whatever the file descriptor you could consider, how much so buffer size you are trying to read, and what is the size you may be get read. Look at this. There is a file something like this. This is a total file which is already stored at our auxiliary storage device, and it does have a huge amount of data. For example, 1024 bytes of data is available with you. So bytes of data is available with you. Now I'd like to read, so let me say 200 or 128 bytes at a time. 128 bytes at a time. So 128 bytes in the sense 128 plus 128, 256, 2 times 256, 256, 512, 4 times 512 plus 512, 8 times you have to read this particular file. Okay, 8 times you have to read the particular file. What is the buffer size in the sense? The buffer size will be 128 bytes. I'd like to consider 128 bytes. And how much size you have been read from the file. So for the first time, it could be 128. So for time being, let me explain by taking a very simple example here, because we need to understand with a proper example here. So for example, my buffer size will be, so B size will be some 10, 15 bytes. For example, you could consider your total file size will be, the file size will be, let me consider, so 20, no, 32 bytes. For example, 32 bytes. Total file size will be 32 bytes. Okay, total data which is being resided within this particular file will be 32. Okay, 32 bytes. So this buffer size will be defined by you in our program hash define b size 15. Something like this you have been defined here. Hash define, so define so b size, let me write bs, so 15. Your buffer size will be 15 bytes. Okay. Now this particular system call could be gets executed for the first time. For the first time it is being executed, 15 bytes will be so extracted from the file. So buffer size will be 15, and whatever the size you have been fetched from the file will also be 15. So here it is, for the first time it is 15, and the t size also be 15, because enough data will be available. For the second time, if you run this one, again 15 bytes will be so extracted from the buffer, and the t size also 15. But for the third time, you are trying to extracted 15 bytes, but you do have only 2 bytes of data which is left over, because 15 plus 15, 30. So remaining 2 bytes will be taken for the third read. For the fourth read, you are attempted to get 15 bytes, but you don't have any data, so therefore it could be fetch 5. As and when, so t size will be equal to 5, obviously read will be generated minus 1. So here, look at the point here. So here, the read operation will be so 15. Size of, whatever they read, it could be always returns only integer. So what is the value which is being generated by read on success in the sense? So based on the defined size and based on the t size, what is the t size? So that could be generated here, that is 15. For the second time also it is 15. For the third time it is 2. For the fourth time, since it is 5, it has been generated minus 1. When minus 1 will be generated, so there is no data to be read from the file here. Your read system call will be unsuccessful for the fourth time. As far as my example or our example, we have taken into consideration at this moment. Okay. So to perform this operation, I believe that you understand what I spoke to you just before. Okay. So to perform this particular operation, what exactly the sequence of operations for every call will be? For every call in the sense, here we have been operated 3 times successful calls, 4th time unsuccessful call. For every time, for each and every time, what are the sequence of operations could be done here? Look at this. So it is user area, and this is kernel area. Let us consider that is user area, and this is kernel area. Okay. At user area, you have called read system call. Yes, read system call could be called by you. Immediately push n bytes. N bytes in the sense the size. Okay, the b size has been pushed. Obviously, push. So these n bytes into your actual buffer. You have been taken this particular buffer. This is actual area where exactly you have been called. So that has been taken into consideration, and they have to take this particular data into that particular buffer. So total data, whatever the A, B, C, D, X, Y, Z, that particular kind of data will be pushed into that particular buffer. After this, so this particular data will be pushed into file descriptor. Okay, sorry, taken from the file descriptor. Taken from the file descriptor. After that, so read system call could be activated. Okay. Then the read system call could be taken. So this kind of operation. So read system call could have a certain amount of code which is being executed. So that could be taken into consideration. After that, so after reading certain amount of data, this amount of data is I'm expecting. Does the same amount of data is being available or not? It could be checked whether the same amount of data will be existed here or not. If it is existed, yes, it has been read. So after reading kernel, a kind of trap will be taken. So how this could be placed into buffer here in the sense, this is the way. A dispatch is being executed. So within this particular dispatch, so here buffer has been defined by you. While writing the program, you could understand buffer has been taken here. Onto the specific buffer, it has been pushed. Okay. After pushing this gets happen, system call handler will be takes place here. Then it will be moved to return to caller. Okay. So look at this first operation, second operation, third operation. So then this is fourth operation, and this is fourth operation. This is so fifth operation. Okay, this is sixth operation. This is dispatch is seventh, and filling the buffer eighth, and this is nine, and send the same information to the caller 10. And after this, so read call will be taken here. That is 11. Look at this. How many number of internal operations are being executed? How many number of internal operations could be gets executed? Try to understand here. Okay. After that, it could be increment. This is the 12th operation. Increment the next statement. Next time, so are there any specific data to be read or not? Okay. So these many operations are going to be took place here. Okay. So these many operations could be took place here. Okay. So okay. So totally 11 to 15 different kinds of operations could be internal operations could be gets happen while one system call is being executed. So this is the specific idea how the system call is being executed. And so we have different kinds of system calls. File related system calls are there, and so inter-process communication system calls are there. So I have prepared only one particular system call. So here, so inter-process system calls are there, and then thread related system calls are there, and then file related system calls are there. So all these system calls will be discussed by tomorrow. Of course, I have prepared one particular system call, that is create system call, and how this could be executed and what are the modes which are available. There are several modes to be executed. So it could not be completed at this moment. So because it could be take a huge amount of time to finish up this particular total evaluation or explanation of create, open, read, write, and all those. So it could be taken huge amount of time. So tomorrow I will finish up this particular explanation, and if possible tomorrow we will see how to create one particular file. Okay, how to create, whether create will be get succeeded or not. Afterwards open. So after creation, does open will be succeeded or not? After open, some reading and writing will be get succeeded or not. Everything will be checked out in a progressive manner. So after completion of everything, we will write one particular program to copy. So the first, second program here is write a C program that may copy a file using IO, standard IO system calls. So full-fledgedly, we have to implement this one. Okay. So this is the agenda, and tomorrow onwards we'll follow this particular agenda. To explain this file-related IO system calls, one complete class will be taken. 130 minutes will, 140 minutes will be taken. So tomorrow we will finish up this one. Meanwhile, we have to evaluate whether how the create will be gets executed, how open could be executed, how read, write, and so lseek will be gets executed. Everything will be explained to you by tomorrow's class, and day after tomorrow we will write the second program. And the remaining, if you understand one system call clearly, I mean one set of system call clearly, remaining will be very easy to understand. Okay. So this is what the point I'd like to mention here. So we'll complete. We'll We will take, we'll continue the same class by tomorrow. Okay. Okay, I'll continue. We'll continue by tomorrow. So totally 18 people are here, I think.